Good morning, this is Ms. Billerbeck, and we're going to talk about 8.2 graphs of quadratic functions. So there's three different kinds of quadratic functions. They all follow kind of a parabola shape, and not kind of, they follow a parabolic trajectory. Like if you throw a ball or a paper airplane, it follows a parabola. Okay, a parabolic trajectory, actually. Okay, so here's a standard form. So y equals ax squared plus bx plus c. So a, b, and c are constants, and x is a variable, and y is a variable. Okay, this a works similarly, but not the same as a slope of a linear equation. And we'll talk about that more when I show Desmos. This is the y-intercept. So the cool thing about the standard form is it gives you the y-intercept. Okay, and if a is greater than 0, that means the parabola opens up like that. So it means this is going to have a minimum right there. So there's going to be a bottom to the parabola, of the lowest point, a minimum. Okay, this equation right here, y equals a times the quantity x minus p times the quantity x minus q, is called the factored or root form. And what it gives us is the x-intercepts. So if I have the x-intercepts, let me see. So if I have x-intercepts, and let's do this. So x-intercepts, and then we have something like that. Okay, so my x-intercepts are right here and here on the x-axis, and this is the y-axis. So this equation gave us a y-intercept, which is this point here on the y. But this one gives us the x-axis, which is the x-intercepts here and here. All right, then we have one other form of the quadratic equation, and this is called the vertex form of the equation. So a times the quantity ax minus h squared plus k, and that gives us a vertex, which is kind of cool. So they all have their merit, but your book is going to be focusing on the standard form right now. All right, so this is the basic anatomy of a parabola. Okay, so if I have a parabola where a is greater than 0, so it's opening up, and I have a point here, which is our vertex, it's the minimum, the lowest point. Then I have my y-axis right here, and that's where it hits it. So that's my y-intercept. And then I have my x-axis right here, and those are the two roots. But then what goes through the vertex is this thing called an axis of symmetry. So what that means is that I could just fold this parabola over there and it'd be the same. See how it's just the same? Okay, so that means that from this axis of symmetry, this is exactly 1, and that's 1. This is exactly 2, and that's exactly 2 away from the axis of symmetry. If we folded this right here, this parabola would lay right on top of itself. So that's what's kind of cool about parabolas. So you really only need to get a couple points. The vertex, maybe 2 points over here, and then you can just count the same distance away from that axis of symmetry to find these 2 other points. All right, let's look at this one. So we want to graph this parabola right here. Okay, so we're going to use a table to start with. So I like to use 0 to give me a good idea what's going on, because that gives me my y-intercept. So if I put 0 in here, 0 minus 0 plus 1 is just 1. So that gives me my first point at 0, and if I make this y, this x, and let's say that's 2, 4, 6, 8, and that's 2, 4, 6, 8, like that, and we have 0. Okay, so 0, 1, so my first point is going to be right here. Whoops. So we'll make 1 point right there. So that's my first point. All right, now let's put in 1 because it's easy. So 1 minus 2 is negative 1, plus 1 is 0. Ooh, that's interesting. So at 1, we are at 0. So I have a point right there. That's telling me if it's going down like that, and I know that A is greater than 1, then it's zooming off like that. So that means that I want to investigate this side a little bit more, because I put negative 1 in here. Negative 1 squared is 1, minus 2 times negative 1, which is plus 2, so I've got 3. Plus 1 is 4. Okay, so this is going to zoom up really fast. So at negative 1, I'm already up to 4, right there. So this one should be way off the chart then, if I'm predicting correctly. So negative 2 is squared is 4, and then negative 2 times negative 2 is 8, plus 1 is 9. So at negative 2, we are way up here at 9. Okay, so 9. All right, so let's try 2 and see what happens. Okay, so we put 2 in here. 2 squared is 4, minus 2 times 2 is also 4. So 4 minus 4 is 0, plus 1 is 1. So we're at 2. X is 2, and we're back to 1. Ah, look, we've got an axis of symmetry right there. So if that's the case, I probably don't need to do much, because I know at 3, if I predict this right, 3 should be 4. So 3 squared is 9. Minus 2 times 3 is 6. So 9 minus 6 is 3, plus 1 is 4. Isn't that interesting? So I can go ahead and say, well, I bet at 4 it's going to be 9 then. Okay, so if I put in all these points, I have 0, 1, and then 3, and I go up to 4. And at 4, I'm way up at 9. And I had that axis of symmetry here going up like that. So isn't it interesting how it's just even across from all that? So now I can just draw my parabola. And it's going to take you some practice to draw nice parabolas. I've been doing it for a while, and even I don't draw very nice parabolas sometimes. It just depends. Sometimes I'm right on, and sometimes I'm right off. Okay, so there we go. A parabola. All right, let's try this one. This is kind of a little harder. All right, so this is the equation for a reflector surface. So a real life equation where they want to figure out what it's, how it will be between 0 and 6. So 0 is easy. 0 minus 0 plus 3. So we have 3 here. 1's not too bad. So actually, I think I want to use some factors of 3 so I can cancel some of these 3's out. Don't you think that would be wise? So let's skip 1 and 2 and go with 3. So 3, if we did that, it would be 2, and then 3 squared is 9, minus 4/3 times 3. Are you seeing why I chose that one? Okay, so that is 2 minus 4 plus 3. So we have negative 2 plus 3, which is 1. Are you getting why I chose 3 now? If you haven't figured that out, let me show you 1, and then you'll feel my pain. Okay, so I have 2/9 times 1, because 1 squared is 1, minus 4/3 times 1, plus 3. Okay, so I have 2/9 minus 4/3, which I have to now make it the same denominator, plus 3, which I have to make it the same denominator. Okay, so this is all going to be, I have 2 minus 12 plus 27 over 9, and 27 minus 12 is 15, plus 2 is 17/9. Oh joy, I want to graph 17/9, not, okay. So if it's got a denominator like that and you want to have an easy time of it, go with factors of 3. Okay, so 6. Let's try 6 next. All right, so 6, we have 2 over 9 times 6 squared, which is 36, minus 4 over 3 times 6 plus 3. So this cancels and becomes 4. This cancels and becomes 2. So I have 2 times 4 is 8, minus 4 times 2 is 8, plus 3, which is 0 plus 3, which is just 3. Look at that. 3, 3. We just found our vertex. Da, 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 da. That's the vertex. Okay, so that means that this is going to be 17/9 because we have an axis of symmetry. So we don't have to do this grueling one twice. Okay, let's just break down. We'll break down. We'll do this one, okay? Just to do it right. So we have 2/9 times 2 squared is 4, minus 4/3 times 2, plus 3. Okay, so we have to do the same thing, so we might as well do it now. So 3 over 3 plus 3 over 9 over 9. So that gives us 8. It's all going to be over 9. And then that's 4 times 2 is 8, times 3 is 24. And then this is plus 27. So this particular one is, so the difference between 27 and 24 is 3, and then 8 minus 3 is 5/9. Oh joy, I want to graph 5/9. Well, let's try it. Okay. So we typically we don't want to graph anything that's not a half or 1. It just makes, we could do thirds, you could do fours, but this is nice. This is not nice. Okay, so, but we could get close. Okay, so we're only going to 6. And so let's do, so our height is 3. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's call that 3. Let's call this 1, and 1, 2, 2, just because these y's are kind of crazy, okay? And that way, maybe there's some hope of graphing 17/9 and 5/9. And okay, we'll see. We'll try. Okay, so this we'll just do 1, 2, 3, 4, 5, and 6. Okay, so at x is 0, we were up here at 3. And then at 1, that's the thing that I'm not happy about. That's so close to 2. So let's call it right there. Okay, we'll smooth it out later. So 2 is close, really close to a half. So 5/9, that's a little more than a half, because 4.5/9 would be a half. So that's probably right about there. Then we have 3/1. And we come back, this should be about the same. And then 5 was about the same as that, because we have an axis of symmetry happening right here. Okay, because that's the vertex, and the axis of symmetry goes through that vertex. And then 6 was just there at 3. Okay, so that wasn't so bad. Gave us a little fraction practice. Yep. Yeah, I think my points were off a little bit there. Oh, I think we'll just ease it out like that. Like I said, you know, it's hard to graph those little things that are, those fractions are hard. Okay, so there we have it. A parabola of the reflector surface. All right, so let's look at, well, what happens when we have the standard equation and A is less than 0? That means that it's not going to hold any water anymore. This parabola is upside down, turned around. The vertex is now the maximum. Someone poured all the water out of the cup. That's what happens when A is negative. So A is less than 1 means it's all the negative numbers. Okay, so we have example 3. Let's graph this. All right, so I don't like to do a lot of numbers, and I like to go right around the vertex if I can. Okay, so I usually work around with 0. 0 tells me quite a bit, because 0 plus 4 is 4, which is my y axis, my y-intercept. So if I label this properly, well, let's label it once we've got our points to see where we're going. Okay, so then if I put in -1, well, -1 squared is 1, but there's a negative, so it's -1 plus 4, which is 3. And if I'm guessing right that that's the vertex, then 1 squared is -1 squared, or -1 plus 4 is 3. See, that was the vertex. And then 2. So I have 2 in there, and that gives me 2 squared is 4. -4 plus 4 is 0. And I'm going to guess this is going to be 0, and it is. Okay, I kind of want to see one more. So let's try 3. See where it is. Okay, so 3 squared is 9. -9 plus 4 is -5. All right, we've got plenty to graph. Okay, so we see that we're going from 4 down to -5. So I've gone into an area where I'm already working, which is a bummer. Okay, so I have 1, 2, 3, 4, and -1, -2, -3, -4, and we'll put -5 right here. And we'll 1, 2, 3, 5, and then we'll do the negatives. And I'm just spacing it out just so we can have a nice view of the graph, the parabola. Okay, -5. There we go. All right. So let's plot these points. So we have 0, -2. Boom. That is an x-intercept. See the x-axis? It just intercepted. Then I have -1, 3. And I have 0, 4, my y-intercept. And I have 1, 3. See how the y-intercept is right on the y-axis, and it's the axis of symmetry, so I can guess that this is going to be right here, and it is, and I have another x-intercept. And then if I go to 3, I'm way down here at -5, and I know if that's my axis here, then I know at -3 I had a point right there. Okay, I can't quite graph that point, but at least it guides me at how steep this is. So it's coming around like that. And then it comes down steeply again. And there we go. So usually 3 to 5 points is plenty for a parabola. So I don't want you to do a lot of points when you're making a parabola. Remember, there's more to do in life than graph a parabola. Okay. Okay, so my chair was squeaking there. Okay, so example 4. Okay, so we want to graph a soccer ball flight, which follows this. H equals -5t squared plus 6t plus 2. So h is height and t is time. Time is always the x-axis. So we are going to put time right here. So here is time, and we're using t for time, so that's time in seconds. Okay, and this is going to be the h-axis because we're using h and t. So this should have been t, sorry. T. Okay, so this is height. And I'm not quite sure what the height is. Let's call it feet. All right, so we have these, we have time, so the 0, ½ second, 1 second, 1.5 seconds. Okay, so we have -5, let's start with 0. So that's 0 plus 0 plus 2. So that gives me 2. I like that. 0 is so easy to work with. Okay, a half. I'm not really feeling like working with a half right now. Let's use 1. -5 times 1, 1 squared is just 1. So -5 plus 6 is positive 1 plus 2 is 3. Okay, so now let's work with a half. So I have -5 and 1/2 squared is 0.25. Loss, and 6 times a half is, well, that's easy, 3 plus 2. So this one's the only troublesome one. So 5 times that. So we have negative, and that's 5 times 5 is 25. So I have no idea why I wrote it 2. 25 carried 2, and then that's 125 with 2 moves of a decimal. So I have a -1.25 plus 5. So that's going to give me 3.75. Okay, so subtract 1 from 5 to 4, and then subtract 1/4, and you get 3.75. Oh, and that doesn't quite fit here. Okay, so let's try 1.5. So 1.5 squared is 25, 7, and then that's going to be 5, 1. So we have 225, we move the decimal twice. Okay, then we have 6 times 1.5. Okay, so 39, so that's just 9. All right, let's look at what we've got here. So we have we have this times 5. So we have to multiply by 5. Okay, so that's 25, carry a 2, and then 12, carry 1, and 11. So 11.25. Right, so we have negative 11.25 plus 9 plus 2. Okay, so that's 11, that's negative 11.25, so we end up with negative 0.25. Ooh. If this is a real life thing and we just went negative, what does that mean? Can we go negative? Can we have negative? Can we go negative on the height? What happens when the ball hits the ground? What's the height? The height is 0 when it hits the ground. So this is bogus. Okay, you can't go below the ground unless, you know, it like went and dug into the ground pretty far, like you really kicked it and it, yeah, it made it into a beaver's den or something. Okay, so anyway, time. Why am I not going to do any negative time? Do we have such a thing as negative time in real life? No, there's no such thing as negative time. So we can't do negative time, we can't do negative height. So we can use this point, though, to kind of guesstimate where it hit the ground. So let's look at that. All right, so we're only going a very short height. So 375 looks like the highest point. So let's label this at 4. So 1, 2, 3, 4 for our height. And I think we're doing meters. That's looking like 4 meters because meters are 3 feet. So 12 feet high makes a lot more sense. Okay, so then on our seconds, we're going to spread it out. So 1, 2, 3, 4. So let's make that 1. 1, 2, 3, 4, 2. 1, 2, 3, 4, 3. Okay. Oh, wait. We aren't doing 1, 2, 3. So let's do 0.5, 1, and 1.5. Okay, so we're stretching it out so we get a really good idea where it's going to hit on the y-axis. And we do have to go down below because it went down below. Okay. All right, so let's graph. So at 0, we're at 2. At 0.5, we went up to 375, which is right here. So that's 3.5, and 375 is halfway between them. So that's not a bad one to graph. At 1, we are at 3. And at 1.5, we are at negative 2.5. So that's right here. Okay, something's a little up. Okay, the reason being is we've got some sort of maximum happening right here and we can't see it. I could do some calculus and find it. All right. So anyway, we don't quite know what that is, but we can find it. Let's see, how would we find that one? So it's somewhere between these two. So let's try 0.75 right here. It's probably going to be closer to this though. But if we do 0.75, it'll at least tell us something about that. So 0.75 squared. So 25, and then that's 37. Then we have 35, 49, 52. And so that's 0.562. Okay, so now we're going to multiply by 5. So that gives me 25, 12, 31, 28, and we're, okay, so 2.28. So we are trying 0.75, and that gives me 281. So at 0.75, I'm at 2. That doesn't make any sense because at 281. Okay, so we have a little problem here. Let me get the calculator out. I must have made a mistake. Okay, so we have 1 squared. One of these is not right. So let me do the 0.75 because that's most likely the one that's not right. Times -5. Okay, that's -2.8. Oh, that's because we weren't done. Ugh, silly me. Okay, and then times or plus 6 times 0.75 plus 2. Okay, that makes so much more sense. Okay, so this point right here is 3.7. So that gets me right here. So if this 375, this 3.7, oh, we found it. These are so close, 3.7 and 375. So our axis of symmetry has to be somewhere right in here. So we should have, okay, so we're in good shape. So see how we get close, we can figure things out, and we don't waste a lot of time with finding all these points in between way out here. We really want to know what's going on with the vertex so we can graph it. All right, so we can graph like this, kind of around the mountain there, and come down and here. So we see that it crosses right about here. So we can make a guesstimate that if this is 1.25, and that's 1.5, and then this would be right here about 1 point, this one right here is halfway, so between 2, 5, and that. So we'd add 13, so 0.375 is halfway. So I'm gonna say this is probably like that little point, that x-intercept, where it hits the ground is gonna be pretty close to 1.47, let's go. Okay, so that's about the time in seconds that it hits the ground, because it can't hit the ground and go below the ground. Okay, and that's what this is saying. And then again, we don't go negative with our time. All right, so that was a lot of time on this lesson, so I will add the Desmos part of the lesson as a separate lesson. So stay tuned and look for that. Have a wonderful day. Bye-bye.